Perfect, better. Welcome everyone this morning. Good that you're here. Welcome in Yokohama. This is the network engineering workshop. Happy that you're here. For me, it's much more than only network engineering. It's also, we are here all together, sharing ideas, inspiring each other on what we do, and work with each other on something what we call the Global Research and Education Network. We'll do a bunch of updates here this morning in this session from 9 to 10:30, and we'll start with Warrick. Warrick will give us an update of what's under the hood at ARNet 5. So the floor is yours, Warrick. Go ahead.
Oh, sorry. Can you hear me now? With ARNet 5, there was a number of things that we were looking at, and we wanted to go and actually have a chat to our customers. So we had a chat and we said, you know, what are the things that you would like us to look at? And the first response we got was, keep doing what you're doing. Don't make the network worse. Keep the network as great as it is. And so we got told, you know, the network is really critical to our business. It provides really good support. We get reliability, redundancy. It's fantastic. But could you look at options to reduce your carbon footprint? So we went, okay, that's a fair call. We can look at that. The second question we got was, can you help me move big data? Now, this is more of a challenge in regards to engaging the researchers. This is not a challenge at a networking level, but more making sure that the researchers know how to use technology and how to actually deliver things. Then there was, how do we better secure our network? Well, this one was interesting. And I think given the current state of geopolitical situations going on around the world, there's a lot of conversations about how do we encrypt our data, how do we make sure, like yesterday there was a great talk on the fragmentation of the internet based on law. And so there's lots of different things that are going on. So we were looking at, can we do MACsec? Could we look at doing quantum encryption? What are our functionalities? How can we make sure that routing is secure? You might have heard me talk about manners yesterday. And so there was a mix of views, but it was interesting to have that conversation. The other thing that came out, which was really interesting, was the customers saying, we want you to encrypt everything, but we don't trust you to encrypt everything. And I'm like, well, hang on a second, you can't have your cake and eat it too. What do you want? And they were like, well, we want to know that we're controlling the keys. We want to know that your network is secure, so we want to encrypt over the top of you. And we're like, okay, that's not a problem. We just want to make sure we understood what you wanted. And then finally, they wanted to have some greater visibility of services. So this led to us doing an RFP, or a request for pricing. Now, for those that don't do this very often, this is a piece of the RFP document that I have heavily redacted to remove a bunch of information, but it's how we actually scored each of the vendors that responded to our RFP. And basically we went through it and we weighted various different bits. We had categories around, you know, is this must have, a should, a could, a want, and probably the biggest one, and I can't point it out at the moment, is the second column that's yellow that has red flag. This was when, as we were reading through the vendor's material, we were looking to see, did the material match something that we had seen or heard of in the press or in news forums or from our NREN colleagues to say, hey, that doesn't work the way they're saying it does. And so these were things that we wanted to make sure that we flagged as things that we needed to test in more detail. So with that, we produced a proof of concept lab, which was made up of both Cisco and Juniper, because they were the two evaluees of our RFP. We actually had 4, but we whittled them down to 2. And so this is one of my staff members racking some servers up to do virtualization, again putting bits into the racks. And this was all during COVID time, so you can see obviously we were wearing masks inside the data centers and doing bits and pieces. And this gives you an idea of how we were building up the lab. But the lab wasn't just physical routers, it was virtual. We actually built a digital twin. Now the reason we did this, and I'm going to highlight this as one of the most important things that I can ever say to you, is don't just rely on a virtual twin. The things that you do find from playing around with physical hardware is phenomenal. We built the entire network of what we wanted for ARNet 5 in the virtual lab and thought, this is great. Then we put it on the physical hardware and bits didn't work. And then we found, oh, it's an FPGA bug. Oh, it's a bug with the way the optic works. And so we actually had to spend time doing the work to actually validate that things were going to work in the real world as we expected. So with that, we built this whole network and it runs today. And the great thing is we can turn around and we can actually turn off the entire network and go, let's do a disaster recovery turn the network back on, let's see what happens. And you'll be surprised. Things don't work the way you expect. Things don't come back and you have to figure out why. So we spend a lot of time playing around in the lab to try and test things, and this is where we also do all of our automation testing and pushing config changes and so forth. Now, I mentioned that we have a number of different pieces of hardware. I'm going to quickly run through them, but these are the pieces of hardware that we actually chose for ARNet 5 for what we call the transport routed network. You could think of this as a Metro Ethernet Forum standard carrier Ethernet. This is how we carry services across Australia at a layer 2 level, and then we present them to routers that are Juniper when we need to do layer 3 in them. So we've got the NCS 5700 D2s. These are 400 gig and 100 gig port machines. We have the NCS 57C3s. We put these into controlled environment huts, CEVs. These are basically a concrete shed out in the middle of nowhere. And on top of it, we have some solar panels, we have some racks inside of it, and this is how we extend our fibre optically around the country. So we have that. Then we have the NCS 540 larges. Again, these are from 10 gigs all the way to 400 gigs. And some of these devices actually do support 800 gig. We're just not playing with that at this point. And then for the internet and layer 3 service, well, Juniper seems to have suited us pretty well in this front, so we found that Juniper, when we were doing our testing, still won out for the functionalities that we were after. So we decided on the MX304, and we're using the MX204, which was interesting because for some of you, you might remember MX204 went end of life and then suddenly had a rebirth and was no longer end of life. They found that they could remake the chips, and so we were able to continue using that. So, to give you an idea of the reference architecture, this is probably the key slide to understanding ARNet 5. So ARNet as an NREN, we're a little different in that we physically put fibre in the ground. We own it, we control it, we maintain it. Now, we can then run from a phobot, a dark fibre service, from one point to another point and hand it off to the customer. We can then take it to the optical photonic layer, so our optical infrastructure, which is made up of Cisco NCS boxes, and we can use that to go across the country or even across the globe. So this is how we connect to Indigo Central, Indigo West, JGA South. And then finally we have the packet core, which we are affectionately calling the TR layer, which is the Cisco routers I was just describing. And this is what does the carriage of services across the country and delivers it to our layer 3, which is the PE router at the top. And the PE router up the top allows us to then talk to various service providers, internet connections, Microsoft, Google, Amazon, etc. Now, the important bit with all of this, and this is, I apologise for some of these pictures, but they are rudimentary, but they're actually really clear to understand when you actually get to look at them. The reason this is important is that you'll notice that there are two green routers. These are our TRs. As I mentioned before, these are our transport layers, but you'll notice that they are connected, and I apologise because I'm having to read it on a very small screen. They're connected to the two blue boxes, which is the layer 3 service router. The way that the service works is we create a service on a Metro Ethernet layer, and we deliver it to one of those two blue boxes, but each blue box is dually connected to the TR layer. That means that if one of the TR routers goes away, the other one takes over and no loss of service from the customer's perspective. If, however, the blue router goes away, the blue router means they've lost that service. Now, there's a reason for this. ARNet has built its reputation over the number of years on the fact that we have diverse hardware, diverse services, and diverse fibre. So we actually tell customers that we want them to connect to two diverse PE routers. And so we make them connect to the two different blue routers in two different locations for redundancy reasons, so that if we do lose one site, the other site continues operating. Now, we've talked about a bunch of things here, and I am going a little fast, so I'll try and just cover the last couple of bits in a little bit of effort. Couple of things. ARNet for the last 27 years, sorry, what am I saying? Last 35 years has been running OSPF. We are no longer running OSPF. We are moving to ISIS. There's a number of reasons for this, and that's particularly around segment routing, being able to do flex algos, and the benefit of this is it's a very simple system. We can associate the IGP metric to the actual distance between our sites. So we can do this based on kilometres. You can do this with OSPF, but it becomes a bit messy. And we're going to use 6PE for all of our routing of IPv6 within this environment. So the reason why SR MPLS was selected, it's inherently simple. It got rid of LDP. It got rid of a bunch of protocols that we no longer really needed, but we wanted to have simplicity. Now, it provides fast reroute straight away using the TI LFA. Flex Algo was important because how many here, and I just asked for a raise of hands, how many here are subject to acceptable use policies on their fibre network? I can see at least a hand, and the rest of you, some of you will have this. We are subject to, on different paths, we are subject to rules of what we can and can't pass traffic over. So we might not be able to pass, say, the commodity internet, but we might be able to pass research and education. And so because of that, we use Flex Algo in ARNet 5 to be able to actually determine whether or not we need to be able to pass that particular traffic. And that allows us to do this by tagging a particular fibre with a tag. In old MPLS terms, this was colouring, but in Flex Algo, there's a couple of other little bits. Then there's the service route to SR bindings, the ability to describe a service and say this is an E-line, an E-LAN, and being able to track where you want it to go and deliver it. I've mentioned a whole bunch of these in passing, but I'll just stop here and just point at the restricted. I mentioned these before. We may not be able to use international offshore links based on requirements. We may do secure links. Those are fibres that we physically own, whereas if we actually have a fibre from a third party that we don't control all the way, we may not put it as a secured link. Now, the important bits that I will just quickly run over is in the old scheme of ARNet, if your traffic was on the left-hand side at the top up here, you would go all the way back. So you go 600 kilometres, 60 kilometres, 300 kilometres, so 960 kilometres to make a routing decision that says you need to go back 360 kilometres to deliver it. In the new ARNet 5 network, you will only go the 600 kilometres. That will allow you to get the traffic to the customer between the two sites a lot faster. The same applies for layer 3, and we've shown that on the diagrams up there. And then the other part, Australia is pretty big, although depending on where you're from in the world, that could be a different opinion. But when you talk about the amount of fibre in the ground and so forth that we have and that we have to maintain, resilience is really important. So we've put routers closer to the customers to be able to make more decisions, and you can tell this by the fact that we've used pictures of brains. And so with that, what we did is we made it so that if there was a failure, we could reroute around it as close to the fault as possible, minimising latency for customers. And that is it. If there are any questions, I'm happy to answer them in the hallway.
Good. Okay, that's fine. One question?
So you are maintaining the optical fiber to connect your universities or the members.
Yes.
So who is actually maintaining the, is it underground fiber? And if it is underground fiber, who actually maintaining the fiber? Do you have the team technically?
Okay, so just to repeat the question, who is maintaining the fiber to the universities? Is it underground and is it managed by ARNet? Yeah. If we have built, sorry, ARNet builds fibre. We have teams that go out and actually builds them. We do bury it underground. We have teams that maintain it. And so we have a series of OTDRs that sit on the end of fibre links in different places so that we can tell when a cut's occurred, so that we can detect, you know, roughly it's this many kilometres away from this point and so forth. But yes, we maintain it. We have teams of contractors that we use to actually go and maintain that fibre, but it is owned by us.
So how often it is cut down?
It's a second question, but I'll answer it very simply with how often does a fibre get cut? I can tell you that it's more common than we'd like.
Thank you, Warrick.
No worries.
It sounds amazing when you say it's only 600 kilometers and optimization. In the country where I'm from, that's still quite a big of distance.
Oh, yeah.
Yeah. And the next speaker is Ariful from Bangladesh, BdREN. He's the manager of data transmission, and he's going to give us an update on what's happening in Bangladesh. Thank you.
So this is the, thank you. This is the second time I am giving the update of the BdREN, what is going on in Bangladesh basically. So we have a fiber connection discontinue of the chain services since 7th July 2024 because of the political issue between Bangladesh and India. It was actually given by the link support given by the NREN, National Knowledge Network by India. And once the issue has been raised, they actually cut down the link, and we were basically out of the service since July to February. Recently, we established the connection in 21st February 2025 with the help of NREN. Now it is connected both NREN and connected to the chain, both NREN and directly to the chain. And big update, we have got the qualified the Meta cache service, and we install for Meta server in our data center on 27th of November 2024. So we also, this is the utilization and the establishment of the connectivity between the NREN and the chain, and the utilization. Just it has been connected 21st February of 2025. And we also deploy a validator, out validator in our network. Still, we are not actually going any action. We are observing, and we found the route which are the not found and invalid and valid routes. And you can have the link of this routinator with this through these IPs. And here goes the our upstream connectivity. We have two IX connectivity, and one is 10 Gbps, another is 1 Gbps. We have the community internet connectivity with 3 separate IIGs. One is BTCL, another is Bangladesh Submarine Cable Companies, another is private IIG. So we had altogether 22 Gbps of internet connectivity, I mean commercial internet connectivity. We had a FNA server, okay, Facebook server, which is capacity 40 Gbps link through this, and we have a Google cache also, and it is 4 Gbps. Other than we had a peer with our Bangladesh Computer Council and the government-owned telecommunication companies. And this is the statistics of our members. I mean our membership in 2023. Actually, it was total number. It was 191. Now it is 335. So in 2023, you'll see we have the 3 categories of membership: full member, associate member, and the industry member. Industry member is same, it is 4, but we increased the associate membership. That is, it was 82 in 2023, now it is 195. And full member, I mean the universities, all the public and private universities, now it is, previously it was 105, now it is 136. So altogether, we now have the 335 member. This is the growth of the research traffic, I mean through chain traffic among the REN. So you can say in 2024, though we are out of the service since July, so traffic is actually low down. Otherwise, it was basically linearly growing. And this is the growth of our community internet. And you can see from 2021, it is actually exponentially growing. Now, till December, it is 7,500, almost 7,500 Tbps. So Eduroam, we last update I gave you the update of we deploy Eduroam in our international one of our international airport. Now it is 3. So you deploy 3 international airport in our country, and we are supposed to go all domestic airport coming days. So this is the user statistics of the Eduroam, the roaming user, and you can find the January 2025 the maximum user 3,282 users roam in our airports. This is basically the resource actually we are going to serve to our members institutes. Previously it was given by the University Grants Commission itself. Now we are the responsible to provide the e-resource to our member services among the universities, colleges, and the research institution. So we actually struggling to make the operation federation. Now it is operating smoothly. We starting to remove open Athens with the Tiger Fed, the Federation of Bangladesh. So in future, we would like to give any other resources like Spring Journal, Nature, and the World Scientific Journal as well. This is the computing resource we have. So we had a CPU of capacity of 1,870 core. Now this year we added 256 core, along with the 15 TB of RAM. We had almost 500 plus portal in our cPanel. We are providing service to our members institutions. This is the new team actually built in BdREN, a software team. This is a work for the AZHAN file sender, and AZHAN community, I mean REN community can send big file through this software, and which has been already delivered and tested. So it is support 21 languages, so you can have your language, of course, and the total file size you can send over using this software is 1 Tbps. So this is the new area that is BdREN has developing and doing, I think, good, and this is the first work for the AZHAN community. And that's all. Thank you.
Thank you, Ariful. Are there questions? No questions? It's really good to see. No?
Yeah.
Am I missing? No. Really good to see that you're growing to a full stack NREN here with all the things that you do besides the network. Thank you. Osamu Akashi. He's a project professor at SINET, and he's going to update us on the 400 gig lines between Japan and the United States and the new design of the GXP in Tokyo. Yeah, thank you.
Hi, everyone. I'm Osamu Akashi of NREN. First of all, welcome to Japan. So this is a brief introduction of the NREN building. So Yokohama is here, and NREN is here. So this is about 1 hour distance by train. So today's my presentation is about the 400 gig line update. So I'm very glad to have good news today. Yep. So this is a brief introduction of the SINET. SINET is an ultra-high-speed academic network in Japan. SINET connects more than 1,000 organizations, including the major university, research institution, and by providing the international circuit, so we are provide the connectivity to projects such as BEL2 or ITER or so on. And SINET also connects the supercomputers in Japan, and also provides a direct connect to the cloud. So each organization can use the these cloud as if they are in the campus or their organizations. So basically, SINET is a 6 years project. So currently, SINET 6 started in 2022 April. So future is listed here. So one is nationwide 400 gig BPS lines, and another future is 5G mobile capability. And one of today's focus point is 200 gig BPS or more international lines. So this is a topology map of the SINET 6 at the beginning of the SINET 6. So as you see, so we as the in Asia area, we ask the Japan Tokyo to Guam line in addition to the Tokyo to Singapore line, and also connect these worldwide 100 gig lines links. So we, at the SINET 6, we increase the bandwidth between Tokyo and Los Angeles and New York. This is the beginning of the SINET 6. And the next step, as you know, worldwide issues, we have to reroute this Japan to Amsterdam, right? So this is a shorter, smaller RTT, 150, but we have to reroute this path. So as the first step, at the beginning of the, in the April of 2024, we select the path via United States. Unfortunately, our RTT was increased from 150 to 220, but we increased the bandwidth of these lines. This is in April 2024. So topology map has changed, and the purple line is this line. And today's main topic is here. Last week, we have a good news. We have upgraded this Tokyo to Los Angeles, New York, and Amsterdam to 400 gig lines. So this is a good news. And at the same time, we upgrade the connection at the Pacific Wave at Los Angeles, and MAFFIN at New York, and Netherlight at Amsterdam. So again, thank you for your support for upgrading this implementation, and we are very glad to have a good news. So I think that this 400 gig line is one of the most longest 400 gig lines in this community. So we will feedback about the operation experience maybe next engineering workshop. So this is another topic. So in the previous
before we go, I think this is worth an applause for the new 400.
Yeah. Thank you. Thank you very much. Another topic is GXP. Previous network engineering workshop, I reported as in planning phase. But we have just finished the procurement, so we are now preparing the implementations in Tokyo new GXP. So this is the structure of the new GXP. It consists of the two 400 gig capable routers connected by several 400 gig lines and deployed in 2 data centers in Tokyo. And these routers are also connected to the current GXP Tokyo. So we are now planning the connection with the ARINAPAD, MAFFIN, NICT, and also NISI. And possible site other connection from the other NRENs is the transport line and Singapore line and Seattle lines. It's a possible connection candidate. So we have another informal request from the connection. So we are very glad to contribute to these communities. Okay, it's all. Any questions?
Thank you. Question for Osamu? No questions. I'm really happy with this new open exchange point in Japan. It's really important for the GREN that we have those stable GXPs for the architecture in the network. Absolutely amazing. Thank you for this. Applause again.
Thank you.
The next speaker is the Chief Digital Officer of MYREN, MOHAMAD. He's going to give us an update of MYREN in Malaysia. Welcome. You're going to do it jointly? Yeah. Oh, good.
Okay, thank you. Good morning, distinguished guests, esteemed colleague, and members of the APAN community. For those of you who may not me, I am AZHAN AMIR. Currently, I serve as the Chief Digital Officer of the Ministry of Higher Education in Malaysia. And my role focuses on driving digital transformation, enhancing connectivity, and ensuring Malaysia research and education sector remains competitive on the global stage. It is a great honor to be here today.
representing Malaysia Research and Education Network, MYREN. Together with me, beside me is Mr. Hafiz, and also my officer, Mr. Kudus, Technical Officer for MYREN. First and foremost, I would like to extend my sincere gratitude to the organizer for providing this excellent platform for knowledge exchange, collaboration, and innovation in research and education networking. Ladies and gentlemen, for nearly 2 decades, MYREN has been at the forefront of connecting Malaysia academic and research institutions to the world. What started in 2005 as an initiative under the Ministry of Higher Education has grown into a robust, high-speed research and education network that empowers universities, researchers, and students across the nation. Today, MYREN is not just about connectivity. It is about collaboration, digital transformation, and future-ready infrastructure. Our commitment is to ensure that Malaysia research community remains globally connected, competitive, and secure in this era of rapid digital evolution. Okay, let's take a look at today's agenda. First, we will go through a brief introduction to MYREN, how it was established and its role. Then we will discuss MYREN evolution, the significant improvement we have made over the years. We will look at our present-day achievement, followed by challenges that we are addressing. Finally, I will share MYREN vision for the future before opening the floor for question and discussion. MYREN was established in 2005 under the Ministry of Higher Education Malaysia. Its main goal was to enhance research and education connectivity by providing high-speed, dedicated internet access to universities and research institutions. Over the years, MYREN has facilitated collaborative research both locally and internationally. By integrating with Global Research and Education Network, REN, MYREN has positioned Malaysia as an active player in international research collaboration. And today, MYREN continues to serve as the backbone for the digital transformation of Malaysia research and higher education sector. To support the evolving demands of research and education, MYREN provide several critical services. High-speed internet access, where MYREN offers dedicated bandwidth to universities and research institutions, ensuring seamless data transfers and global collaboration. Then, EduVPN and EduRoam, secure Wi-Fi access across university, enabling students and researchers to connect securely from anywhere. Then, network connectivity services, we are connected to Asia Connect at 10G to ensuring high-speed global research connectivity. Network monitoring and management is tools to monitor and manage network performance, ensuring minimal downtime. And technical consultation and support, where we assist institutions with network planning, security, and optimization. Okay, let's take a look at how MYREN's infrastructure has evolved. MYREN operates 7 POP across Malaysia, connecting 171 institutions. This includes 23 public and private universities, 10 hospital universities, 4 government agencies, and 140 polytechnics and college communities. Our peering and IP transit connection include 2 IP transit providers, 3 private peering agreements, and 1 public peering connection at the Malaysia Internet Exchange. MYREN is part of Asia Connect, Google Peering, and the government data centers, ensuring seamless national and international connectivity. Over the years, MYREN has undergone significant enhancements. Network capacity has increased by 60G, from 40G to 100G. And additional, 8 locations have been added, including a new POP at Cyberjaya Data Center. And we have expanded to 240 locations, adding 69 new institutions. MYREN now serves as the primary internet gateway for all universities. Network equipment refreshed in 2024 to enhance performance. Core network upgraded from 10G to 40G. SD-WAN deployed at 104 locations, ensuring better traffic management. And direct DWDM links established for all universities, improving connectivity to our core network. Today, MYREN support a wide range of 240 institutions, including, as I said earlier, we have public universities, hospital universities, government agencies, polytechnics, and college communities. And our estimated user base around 4,000 to 20,000 users per universities, and then 800 to 1,200 users per polytechnic, 100 to 300 users per college community. The broad coverage makes MYREN a critical enabler of education, research, and digital connectivity in Malaysia. Several key improvements have been implemented. Core network upgraded from 10G to 40G. MYREN SD-WAN project completed, ensuring better network visibility and management. IP transit upgraded to 100G, significantly improving internet capacity. All public universities now use MYREN as their primary upstream provider. Over 900,000 users, including researchers, staff, and students, benefit from MYREN's network. And network flow monitoring has been implemented to improve security and traffic management. While we have made significant progress, there are challenges that need to be addressed. One is about bandwidth management and capacity planning. And as digital demands increase, we must ensure efficient bandwidth allocation. Cybersecurity risks. A larger network means higher risk of cyber threats like DDoS attacks and ransomware. Network visibility and monitoring. The expansion of MYREN require better traffic visibility for improved performance management. Cost management. With growth come higher operational costs, OPEX, and quality of service assurance to ensuring consistent SLA and network reliability for all users. Looking ahead, MYREN aims to enhance and expand its services, seamless regional and global connectivity, to expand connection to Arena Pack, to strengthen global collaboration, resilient and secure connectivity, to implement a robust cybersecurity framework, and to provide regular cybersecurity training. Promoting collaborative research, enhance research collaboration through Asia Connect and Arena Pack, and then shared research and education services to develop a national research data sharing platform, and to build a shared high-performance computing HPC infrastructure for advanced research. Ladies and gentlemen, as part of the Asia-Pacific Advanced Network, APAN, we recognize that connectivity alone is not enough. True progress happens when we collaborate, when we share ideas, resources, and innovation to drive breakthroughs in research, education, and digital transformation. MYREN is committed to strengthening regional and global partnership with networks such as Asia Connect and Arena Pack to facilitate seamless knowledge sharing, high-performance computing, and data-intensive research collaboration. For this opportunity, I encourage all of you to explore how we can work together to enhance research networking, improve digital infrastructure, and support the next generation of research and innovators. Your insight, experiences, and expertise will be invaluable as we chart MYREN's path forward. Once again, I thank APAN for this opportunity, and I look forward to sharing MYREN progress and hearing your thoughts during the Q&A session. Let's move forward together to bridge the past and empower the future for research and education networking. For that, I thank you.
Very much. I really love your call for collaboration here. Before you leave the stage, are there any questions?
Yeah, if you have any question, actually, I bring my too strong guy here. If you have any question, so my colleague will respond to you.
Super. Okay. Use the hallways and the coffee breaks as well for questions to the MYREN team. Next up is Satoshi-san. He is Information System Officer at the MAFFIN project under the Ministry of Agriculture. And you are going to update us on network operations for MAFFIN, policy-based routing, satellite connections, and DDoS attacks countermeasures. Floor is yours when you plug in the plug.
Good morning. Hello, everyone. I'd like to thank you for opportunity of this presentation today. My name is Satoshi Kurohori, and I work for AFRIT. AFRIT is Agriculture, Forestry, and Fisheries Research Information Technology Center. AFRIT operates MAFFIN. My presentation is composed of the content shown here. First, AFRIT service is for researchers. Second, outline of the MAFFIN network and update. Third, small effort and as recent examples of MAFFIN operations. AFRIT provides various services to researchers at the Research Institute of Ministry of Agriculture and Forestry and Fisheries. NSS Network Service System provides email and file sharing systems. SCS Science Computing Systems provide supercomputer. NRENs Network Library System provides integrated database and library services. I will discuss MAFFIN on the next slide. MAFFIN is high-speed network that connects to about 17 access points of the 6 research organizations include branches. We are based on Tsukuba City, about 50 kilometers northeast of Tokyo. Tsukuba City is regarded as a science city, and most of the headquarters of National Agricultural Research Institutes are located in this city. MAFFIN has been operating 10 Gbps MAFFIN PH link jointly with the DOS-ASTI of the Philippines. We collaborate with APAN and AZHAN Connect to support domestic and international research and education network. I will introduce some updates of MAFFIN. We plan to upgrade the internet connection from 20 Gbps to 100 Gbps in 2025. Responding to a proposal from Nord.net, MAFFIN is ready to offer a part of the vacant space in the MAFFIN rack in Tokyo and connection to GXP Tokyo for establishing the Nord.net equipment. This initiative would improve connectivity between Europe, Japan, and other parts of Asia and support research and education networks. They support institutions, projects, and higher education services in this area. We operate based on A core as our basic principle. A core means anytime, anywhere, we provide a collaborative research environment. Improving the communication environment requires a budget, but it is not something that can be easily increased. I'm sure it's the same for every organization and every network. So here are two small efforts aimed at improving communications without a large budget. The first one is the effort to improve the communication environment. The second one is the effort to ensure stable daily communication. I will discuss the trial introduction of satellite lines for research sites. Many research centers of agriculture, forestry, and fisheries are located on remote islands in the mountains, on the coast, or on the ocean due to geographical necessity. In these areas, it is not easy to develop infrastructure. At a network line that is not affected by the geographical environment, we installed Starlink lines on a remote island, Ishigakijima, and in the mountain, Nikko. As you can see in the photo, we installed antennas for each of the facilities. We found that there was no big difference in line speed anywhere. Downlink is about 200 megabps, while uplink is about 20 megabps. It is a characteristic of Starlink that uplink is lower. In addition, packet loss from a few seconds to a few minutes occurred irregularly, perhaps a characteristic of low Earth orbit satellite links. As a result, it was found that though it is not suitable for use alone as a research network, it can be used for the backup purpose and so on. Next, I talk about DDoS attack cases. The first one was in March 2024 at midnight with a DNS flood attack of 28 million sessions per hour. As the source IPs of the attack, we identified a lot of those of Google Cloud. We had to temporarily suppress the source of access, taking care not to affect normal use. In the October 2024 case, the destination ports were not only UDP53, but also TCP53. Next, I would like to talk about the effort to optimize load distribution we conducted in 2024. As the cloud service became more common, the internet traffic has been rapidly increased. We often detected heavy load at the timing of DDoS attack and Windows update. As it was impossible to install additional machines, we had to optimize the existing network configuration, maintaining redundant configuration, and maximizing the performance of the firewall at the same time. In the former system, the left side the left side was the main route based on the BGP MED value. To ease the heavy load and optimize the distribution, we divided the user networks into two groups and distribute the traffic based on policy-based routing. We specified the subnet to take the second route. For internet direction, we forward packet from specified subnet to second route based on policy-based routing. For MAFFIN direction, the router 3 on the second route advertised the specified router 3 on the second route advertised the specified subnet to router 1. Packets to the specified subnet are forwarded to the second route based on the longest match rule. Next, about the redundant configuration. The rule of policy-based routing applies absolutely. So traffic on the specified subnet cannot switch to the first route if a failure occurred on this route. Therefore, we set the policy-based routing setting to be cancelled when a fault is detected. This server monitors the second route. When a second route failure is detected, the server connects to the backbone L3 switch via SSH and cancels the specified subnet settings of policy-based routing automatically. Then the packet takes the first route via BGP. The figure shows the amount of traffic before and after the application of the route distribution. We determine the specified subnet based on the traffic volume survey. The traffic volume of firewall 1 before application was about 10 gigabps. After the application of the load distribution effort, the traffic value is evenly distributed. Conclusion. In summary, in daily network operation, cyber attacks and demand of users are becoming more diverse, but it continues to divide method for operation. That concludes my presentation. Thank you for your attention.
Do we have any questions? No questions at all? Isn't that early in the morning to ask questions? Thank you. I learned a lot. I was not aware of MAFFIN at all. So it's really useful to really understand for me what you are doing and why you are there. And I love your call for more collaboration on cyber attacks and security as well. Next up is Mr. Sanjeev from India. He's the director of ERNET. Do I say that correctly? And he will update us on what's going on within ERNET. Yeah.
So thank you very much and good morning to everybody. And this presentation I have kept very simple, not technical on that in that sense. This is about Education and Research Network of India, ERNET India, for which I am currently heading this organization. I'll take you through the activities which we have undertaken in the country. Before that, it is a first glance of our ICT market in India. We have close to around 1.2 billion mobile subscribers, and most of them are wireless subscribers. And we have, out of that, 662 million as urban and 528 million as a rural subscriber. We have close to 85% of our tele-density. And out of that, in urban areas, tele-density is 131. That is, every person is keeping more than one, on an average, mobile with them. And rural tele-density is around 60. Total internet subscriber as of September 30th were 971.5 million. And out of that, close to 945 million were broadband subscribers. And urban internet subscribers are 566 and rural 405. If you see the overall data consumed in India is close to 60 exabyte data we consume on internet. And average data consumption by this subscriber is close to 23 gigabyte per month per subscriber. So that's a humongous, you can say the total download, and it's a very big market for us. Coming to about ERNET India, we are not for-profit autonomous scientific organization under the administrative control of Ministry of Electronics and IT, Government of India. And we generate our resources by way of consultancy fee, planning and execution of projects, by way of providing services on VSAT, domain, DNS, cloud services. And we do not receive any as such financial support from the government. We generate our own resources, including salary to our staff. The focus areas currently which ERNET India is having, we are into the IT infrastructure and networking communication services. With that, we have VSAT communication network, complete network, which we are connecting all remote areas of the country all education and research institutions which are in remote in various islands in India and in the remote areas where it is not possible to go through microwave or optical fiber network. There we are connecting. Second, the area which we have expanded recently is about the setting up of the data center, particularly for the cyber security purposes. We have recently established data center of close to 150 racks with more than 500 servers. And we provide the Wi-Fi campus services also to the universities and colleges. And our total aim is to have this digitization of all the education and research institution in the country. And so that whenever a situation like a COVID type of situation comes or because of any weather conditions, if there are problem in the opening of the education institute, then through digital medium, education should not suffer and it should continue. With that aim, we are actually working. In IT-enabled services, we are having services exclusive. We are the exclusive domain registrar for all education and research institutions in the country. So any domain which is having ac.in or edu.in, they are all registered with us. We provide the DNS and web hosting services on cloud, and we provide the eduroam services, as has been discussed by my previous speakers also. We are the exclusive eduroam network provider in India. And we are expanded into software development and capacity building, particularly in cybersecurity areas. In smart education and training capacity building, we have close to thousands of classrooms we have connected through smart virtual way. Particularly, it was very helpful during the COVID time in the country. And we provide the capacity building for information security and education awareness trainings. Work-based learning also, we provide those all college students who are in the final year or who are just about to go to the field. We provide them work-based learning so that they are trained there and then their skills are developed so that they are useful to the industry. And we provide the smart classes in the schools, particularly in very, very remote and inaccessible areas, particularly those where the tribal population lives. We connect all those education institutes using the digital infrastructure and connectivity. We have got two centers for R&D purposes, wherein we are providing advanced optical communication testbed for testing the latest or advanced optical technologies. We are also into the R&D of metro area quantum access network for quantum-based technologies. We are into QKD also, ultra secure quantum key distribution. Then IoT sandbox to test the IoT devices. We are into R&D of this. And we, with the prestigious institutions like Indian Institute of Science or Indian Institute of Technology, we do the collaborative research in other areas like tactile cyber physical system, Li-Fi or visible light communication for urban and rural areas. These are the focus areas where ARNET India is working in the country. As I said, we have connected this remote inaccessible or island areas through VSAT network. Several colleges we have connected over Wi-Fi and smart classroom and eduroam services. As I said, we are the domain registrar for all education and research institution, where we have more than 18,000 active domains presently with us, and we provide DNS services to hundreds of institutions. And there is an integrated portal we have launched recently, wherein all the services are available at click of button through the portal. And as R&D in cyber security we are doing and capacity building. So these are the broad areas where ARNET India is working, and we are now expanding in cloud-based services now, providing web hosting, email hosting services, and learning management system, so that any education institute can design their own website using our portal. and they can have learning management system also self-designed. No need not to go to any developer for that purposes. And for data center and software development, we are providing the services. And we are open for the collaboration with the other RENs in these areas: digital connectivity, digital infrastructure, domain services, various other services, and collaborative R&D. So I would welcome any collaborative opportunities which can come forward to us. Thank you very much. Any questions?
Thank you so much. Any questions for Mr. Bazal? Well, thank you again.
Thank you very much.
Again.
Thank you, everybody.
I promised you 6 updates this morning, but we have an extra one. Eric Lu from Taiwan wants to give an update as well. So, floor for you. And after that, we'll go to the coffee and tea.
Hi, everyone. I come from Taiwan. And thank you. We talk about the networks, RNE networks in Taiwan. My name is Jia Xian Lu. Can call me Eric or Jia, maybe simple. And my email address is here. And in Taiwan, we have 3 members about the network. It's the TARNET and the TAREN and the AZHAN. The AZHAN is us. And in Taiwan, the TARNET and the TAREN for the education network inside, and the TAREN and the AZHAN out of Taiwan. And the blue part is the AZHAN. The green part is TAREN networks. And the top of the little picture is the TAREN, the network for the US and Singapore. And we have the SINET has joined the SOE in Singapore, and we also joined the APEC JP in Tokyo. And our status is the 2025 to 2028, and sorry, okay, and that's our structure. Just a detail.
Thank you, Eric. Very short, very short. Thank you for this update.
So if you have interested with the TARNET, can call the TAREN and me, and we change the information to the TARNET. And thank you. Thank you, thank you.
Thank you so much. It's time for a break, I think. Thank you, speakers. Thank you all for being in this room. Continue the good conversations and continue building on what we do together here for research and education. Applause for all.
So good morning, everybody. I'm Panda from WIDE Project and the ARENAPAC. Welcome to Japan and Yokohama. So WIDE Project is one of the co-hosts of this APAN 59 meeting. So welcome to Japan and enjoy Japan. So today I'm gonna briefly share ARENAPAC update. So I think many of you know what the ARENAPAC is, but I'm gonna briefly share the concept of the ARENAPAC first. So ARENAPAC is the project of the Asia Pacific Internet Development Trust infrastructure that is their subsidiary of the APIDT, the trust, and the fund comes from the APIDT, but their ARENAPAC network is operated by the WIDE project, and this project was started in 2020, and the mission of the ARENAPAC is to establish the submarine cable cables in Asia Pacific for collaboration with the global research and educational network community. And the WIDE project has been operated their domestic research and educational network for a long time, at the beginning of the internet. So the WIDE project is collaborating with their other partner project like AIII or SOASIA. So I think the SOASIA has joined the APAN community, and some signing ceremony will happen in the plenary today or tomorrow. Yeah, so please come to the plenary session for the detail. So and this is the Arena Pack, and we are also collaborating with the other global research and education network like NSF, Internet 210, Asia Connect, APAN, and so on. And we are also a member of the APONET. So we are try to extend our infrastructure to the Asia Pacific and accelerate the collaboration, research and educational collaboration over our Arena Pack network with collaborating with the other international NRENs. So this is the current Arena Pack topology. We started from the Tokyo Guam 100 gig circuit, and we extend our network to the Malang, Indonesia, Quezon City, Philippines, and Singapore. The Singapore Guam is the joint operation with the other 3 parties. And we're going to soon have a Singapore, Penang, Malaysia circuit. So all the circuits are 100 gig. So you can download this map from the arenapack.net webpage. So the Arena Pack is actually their submarine cable infrastructure based on the submarine network, submarine cable infrastructure, and we are operating layer 2 and layer 3 networks. So we have AS number, and we are also appearing with their many partners like WIDE project, GXP Tokyo, at Tokyo, and at Guam, we are appearing with Warrick, ARNET, SINET, and SINET. And we are at the other location, we have partners. So for the Malang, we are appearing with the BdREN and the University of Brawijaya, Abbas. Thank you, Abbas. And at Manila, Quezon City, we are appearing with the President Asti. Is there Bani here? Okay, so, and we're going to soon have the Penang's pop next week, next Monday to Tuesday time frame. So and we're going to appear with the USM. And the morning session, the first session, the MYREN, the executive explained about their collaboration with the Arena Pack. So we are going to connect to the USM, and that could be extended to their MYREN soon in near future, I hope. And we are collaborating with the other NRENs for the research and educational purpose, of course, including some experiments. And for the Penang circuit, we signed MOU last September, and this is the signing ceremony picture. And then we're going to soon have a Penang Singapore circuit. Actually, the circuit is ready, but we're going to install the equipment next week. So this is about the Penang circuit. And during the operation, we have a big outage for the Guam Philippine circuit last year, starting from actually 2 years ago, the December 2023. And but it was recovered last year, July 23rd of the 2024. So but this outage was actually caused by the fiber cut. So to get the permit for the fiber repair ship, it took very long time. So it took about 7 months. So I think the submarine cable is stable in terms of in terms of the long-term span. But once the fiber is cut, it will require more time compared to the terrestrial circuit. So, here we have backup. The APONET and their SING, that is the Japanese domestic REN MOU collaboration scheme. The MAFFIN provided the backup circuit for us. So the MAFFIN has their Tokyo Philippine 10 gig circuit. So during the outage of the ARENA-PAC 100 gig circuit from Guam to Philippines, we could be survived with the MAFFIN circuit there. So this kind of the backup is very important for the resiliency of the research and education network, especially for the international circuit. Because Japan is the island country, so we definitely need submarine cables. So we need to think about the resiliency for the submarine cables. And beyond that, beyond the ARENA-PAC topology, we contributed to several experiments. I think this kind of the experiment may be explained by NICT people later. But last year we contributed to the supercomputing conference experiment conducted by NICT, NII, and AZHAN. So the ARENA-PAC is one of the that was the 1200 gigabps path between Tokyo to Atlanta. So we contributed Tokyo Guam 100 gig circuit for their experiment. And I don't think I explained this. This was in 2023, but I think I didn't explain this experiment in the APAN community on the network engineering workshop. So I want to explain this one. So thank to Francis and Simon for contributing this experiment. So 2023, we conducted a remote surgery experiment or demonstration collaborating with the NUS, National University of Singapore, and Fujita Health University. Yesterday, actually, Francis mentioned this demonstration in the APONET AEL joint meeting. So I want to add this one, the demonstration video here. So so this is from the YouTube video. So this is the Hinotori remote surgery robot. So this is the surgery robot, and the cockpit is the left top one is the cockpit, and I think I can skip this kind of the interview. Yeah. So this is the cockpit. So the cockpit was in Singapore. And the surgery robot was in Nagoya, Japan. And the surgeon, the doctor can operate the Japan's robot from the Singapore. And the doctor says the latency for the operation requires less than 100 milliseconds. So we wanted to test the actual latency that the latency limit where the doctors can do the operation. So we use the 3 paths for the different to test the different latency. So we collaborated with the NICT, NII, and ARENA-PAC to create a different latency path. So the shortest one is the SINET. So this is the direct. This is about the 72 millisecond round trip time. And the second one is the JGN, via Hong Kong. This is a little bit longer than the shortest path. And the third one is the ARENA-PAC. This is via Guam. So the latency will be 120 milliseconds. So that 120, the doctor says, no, we can do the operation. So never, but they tested that. Because for the resiliency purpose, this kind of the backup circuit is important. So the 120 millisecond is better than nothing. The fiber cut disruption. So they retested that. So this repass. So finally the doctor can do the operation even for the 120 millisecond, because the doctor is the very good doctor, the professional. So so for the beginner, I don't think that 100 millisecond is the limit, but the professional doctor can do the operation for the 120 millisecond. Anyway, so, but this kind of their demonstration or experiment cannot be done without, I mean, they can never be done without their collaboration with their, this kind of international collaboration. So the thank to the NII, AZHAN, and SINET for contributing their effort and the circuit for this kind of demonstration. So we successfully done this experiment. And the last year, I think the end of the last year, the December, the paper journal was just published. So yeah, thank you for and congratulations, Francis. Yeah, and this kind of collaboration is very important, and we want to contribute to this kind of state-of-the-art, cutting-edge demonstration experiments from the ArenaPack. So, and I want to note one more thing. So we are operating the APAN 59 meeting space network here. So if you're using EDROM or if you're using APAN 59 network, that you're in the ArenaPack network. Maybe their geolocation might be Australia because we are, I mean, our hub is Guam, so I'm not sure what's happening, but their geolocation may be in Australia. So this is their, so in the venue, the equipment is donated by Cisco, thank you, and the circuit from here, the venue, I mean, close to the registration desk to the SINET, their center, is provided by NTT. That is 100 gig. And the 100 gig circuit to the Otemachi, Tokyo, and we are connecting to the ArenaPack. So that is via APAN JP circuit, so and the SINET. So we extend the ArenaPack network via SINET and APAN JP network. I think Son-san will present something later about the VPN or the BdREN extension. And this is our topology. And I want to thank to the NOC volunteers, student volunteers. The Tomine-san and I are not students, but the other people are students. So I want to thank to the student volunteer and the network systems supporters, Cisco and NTT East. So this is from ArenaPack. Thank you very much. Go ahead. You sure?
First and foremost, thank you very much. And it's amazing that the NRENs have come together to enable things to happen. It's not only just the latency that we constrain, but how we reconfigure, how quickly we do that, and how we can operate beyond our boundaries. You know, it's NREN, ArenaPack working together. I really have to thank the doctors were very, very happy there. At first we went there and said, this cannot be done. And we tested and we found that, hey, there's some blocks along the way because set up by university, they capped what the limits were. And we have to work with them. And Simon and Seong Ying, the network engineers, have to work very hard with them. And Panda has to come in as well. Because they have so many VLANs within that. And you have to private it, you know. But that demonstrates that let's work together and we will solve the problem. And the doctors were so happy when they finally got the thing running. And there is a latency delay requirement. Okay? So the NRENs are not only just high speed, we are very agile, you know, to enable things to happen. So I think cooperation like that and demonstration of our capability is very, very important. That's how we differ ourselves from the commercial internet. Commercial internet, you can't change anything. You just go by whatever they provide you, you know? And that's all, unless you want to buy a new link just for a demo, and that is really, really expensive. I'm going to ask a request to Panda. You say we got 100 gig, right?
Yeah.
Can we try and push it afterwards?
Pushing what?
Pushing the bandwidth. Do you have a landline? Wi-Fi cannot do it. We have a DTN node in Singapore. We're trying to see whether we can push how high that is.
Does anybody have a 100 gig server here? If you have, we have one spare 100 gig port there, so we can push the traffic to your. I2 or anywhere.
That's
maybe.
a challenge.
Bandwidth challenge.
You should have told us that way ahead. We should have brought one.
Yeah, we have 5 more days. So
5 more days.
If you go to Akihabara and buy a new server and they put that into our router and try the traffic to the internet to somewhere.
Yeah, because I think in the old days, when we hold APAN meeting, we actually have demonstrations within APAN meeting itself, and really push the network and show what can be done. So if you have a quick idea of what you can do, not necessarily 100 gig, but maybe a few gig, run it, see how it goes, or maybe test how it goes back to to your home organization. Maybe next time in Hong Kong. Because I think it's sometimes very difficult because pulling the link into the exhibition hall is quite difficult. But just now when you mentioned you got 100 gig, wow, I wish we knew it ahead of time and we could do a demonstration between Tokyo and US or Tokyo and Singapore or any other countries and push the network and see what can be done.
Yeah, I think we may be able to push their 8K compressed video to the United States from here if we have a 100 gig. Oh yeah, maybe.
Okay.
Okay. Any other questions for Panda? All good? Yeah.
Thank you very much.
Thanks, Panda. Yeah. Actually, the low latency is something very important, especially for remote surgery, right? The doctors were sharing with us that they needed that to give that more realistic, real-time haptics that they can feel what's happening. And that, we all know it's not really possible when it comes to the commercial nets. Okay, the next, Ken. Okay, so the next one is via remote. Eva, she'll be sharing on, she's the strategy and policy officer at NorduNet, and she'll be sharing on the Polar Connect, how to navigate the challenges of the Arctic cable laying. So let's switch over to her. Thanks. Hi, Eva.
Wow, that's good.
Good morning, everyone.
Okay, you're online, I see you clearly.
Good to see you. I'm sorry I cannot be with you there myself, but I really hope you enjoy the presentation, and I hope you're enjoying APAN. I heard beautiful cherry blossoms. I'd like to share my presentation. Somehow I'm having issues with sharing my screen. Can you see the slides?
Yes. Yeah, I see it. Okay, great, thanks.
Good. Thank you. So thank you for the nice introduction. I would like to give a brief update on where we are with Polar Connect and how the development is continuing for us. So very quickly about NorduNet. So NorduNet is a collaboration of the 5 Nordic countries, Nordic meaning Northern Europe. So Denmark, Iceland, Norway, Sweden, and Finland. And NorduNet operates a global network that interconnects the research and education networks in the Northern Europe and connects these networks to the rest of the world. And Polar Connect, for those who are not aware what it is, so it's an initiative to obtain secure and resilient connectivity through the Arctic between Europe and Asia and North America for the purposes also of research, innovation, and education. We see Polar Connect as part of this Vision 2030 for Arctic connectivity, where several submarine cables over the Arctic form a ring structure consisting of, as you can see, several cables. And the Polar Connect being the one direct route passing under the ice cap of the North Pole across the Arctic Ocean between Europe and Asia. We see Polar Connect to add additional value to the global internet and global connectivity. This new route that we propose would be complementary to the Suez connections, which are challenging at the moment, creating a new transport corridor for connectivity. This would add majorly to redundancy to the global connectivity, global internet. We see it as a fast track between Asia, Europe, and North America, because we know it will be the shortest possible path between the continents. And we see it, this route strengthening, supporting the digital resilience of the involved countries, regions, continents. And moreover, we believe that this route will be safer, as it will be protected by ice on the North Pole, protected from human activities like fishing and anchoring, which are the most common accidents for damage for submarine cables. And we're also, in developing this project, we're collaborating with the Far North Fiber as much as possible to see how we can create a resilient structure across the Arctics. Arctic connectivity is really very relevant for the European Union. The support is expressed through various EU-funded projects that help us in stages develop Polar Connect. Arctic connectivity is also a very important element of Japan-EU digital partnership. As you all know, that deploying submarine cables involves several stages, but laying cables in conditions where no one ever has built a submarine cable is not an easy task, and it will require really extensive preparations and planning. And here comes the help of the European Union funding, and we can slowly progress, achieving step by step the progress with Polar Connect. So we've been able to verify that it is possible to lay the cable through the Arctics, even when you have several meters of ice there. We know that the technology required to lay the cable across the Arctics requires 3 vessels, meaning that we will need 2 icebreakers and 1 ice-strengthened cable laying vessel. We've been collaborating with the Swedish Polar Research Secretariat, who was able to confirm this and help us understand the technical requirements. So one of the prerequisites that is necessary for laying Polar Connect is another icebreaker. And Sweden is planning and preparing to acquire such vessel. Very important part of the new vessel that will be built. This is the icebreaker. It's a research vessel, but also it will have the capabilities to repair and help with submarine cable operations and maintenance. It will be the second most powerful icebreaker, apart from those that are nuclear powered. So before any submarine cable touches the seabed, another very critical step is designing the route. And again, thanks to the UCO funding and a successful collaboration with Stockholm University, we have been able to evaluate several Arctic routes, initially 4 of them. And the second one, you see in the image here, the second from the top, looks currently the most suitable one. For this desktop study, we used openly available data about the Arctic seabed. But you have to understand that this region, the Arctic region, is heavily unexplored. And the results of this study are only very preliminary. Therefore, we continue with the effort. And to be able to recommend a final route, both technically and economically feasible, we need to do a more detailed mapping of the bathymetry, so the seabed topography and seabed geological composition mapping, because nobody ever laid a cable before, so there's literally very little data that we can find about the surface or all the sensitive seismic areas in the Arctic. So planning and gaining more knowledge is really crucial for us to define the final route and to understand the seabed conditions that are there in the Arctic. So in the coming 3 years, with the help of the Swedish Research Secretariat and their icebreaker Odin, we will be conducting seabed surveys in the coming 3 summers. And the data from these expeditions will be fed into these visualizations of Arctic seabed and will feed into further modeling of the Arctic route. So what we're trying to do here is the goal of the simulation that we are running together with the Stockholm University and the Swedish Research Secretariat is to create a digital twin of the Arctic Ocean, if I may say so. And this will help us design and select the best possible route for Polar Connect, which is geologically stable and doesn't present any severe hazards to the submarine cable. And using the data from the simulation, we'll be able to set the requirements for the types of the cable to be used in the areas there. And once this is finalized, we can finally work on the marine survey and start ordering the cable itself. So a little bit about the seabed mapping that's going to happen in the coming 3 summers. So the Swedish Polar Research Secretariat have a really extensive expertise navigating the high Arctic. This expertise comes from more than 30 years of expeditions in the Arctic. And as I mentioned before, as this area is very poorly mapped, they will use the beam on the icebreaker Odin and will scan the seabed and will then get the information about all the details there, including the sedimentation, which is an important factor in the simulation of the route. And then collecting all the data will every year improve the model and work towards finding the best option for Polar Connect. But creating the route is not the single task that we need to complete. We need to also carefully plan the installation logistics. Arctics are amongst the toughest conditions in the world. There are significant challenges with the extremely low temperatures, not only for the vessel operations, but for all the nooks and crooks in the vessels. It is more complex than regular cabling operations, and there's presence of really hard sea ice, strong ocean currents, and drifting ice sheets. And it poses some risk for the installation itself and for the crews with the physical damage. So every tiny detail needs to be carefully planned. Additionally, there might be ice that is several years old, which is hard, but not as hard as in the archipelago close to Greenland and Canada, which can be harder than concrete when the ice age is 4 years and above. No vessel can break through such ice. However, this is different in the central Arctic Ocean. We also have a very short installation window due to seasonal ice. And to plan the operations properly, we need to reach the ice edge with a cable around August. So we'll be able to cross the ice cap during summer times. We also do see it as Polar Connect as a smart cable. So as part of the currently running Polar Connect Step 1 project, we'll also devise a roadmap for sensors to be installed on the cable, if possible, and where. So we're collaborating not only with the research community, but also with the industry that develops the sensors to know what's coming and to be able to factor in the latest type of sensors. And we're talking and gathering requirements from the science community. And we really think this would contribute highly to climate research, being able to get the continuous data from the Arctic Ocean, from the central Arctic Ocean, where it's mostly interesting for our researchers. Briefly, how all the timeline for Pula Connect looks like. So we are in 2025. We're in the time where we're going to do the seabed surveys. We're going to focus on starting to build the consortium, working on the architecture, the landing stations. And these all activities that you see on the screen will be heavily supported by the European Commission and the 5 Nordic NRENs. And we'll develop the project until we're ready to hand it over to the commercial consortium. And as you can see, we're still planning to be able to deploy the cable with careful preparations early 2030s. Briefly to conclude, we do believe that this will be the shortest path that guarantees really low latency, as I just heard, really relevant for remote operations. We have been successfully proving the feasibility of this project, and we continue to work to find the best route and help de-risking the project and making it attractive for investors. We'll be working with vessel operators and owners to create the cable maintenance plan for the Arctics, as it is currently Arctic Ocean is not part of any submarine cable maintenance zone, so that's also something for us in the future to do. And we're also heavily believe it's gonna be a part of research infrastructure with the sensing capabilities. With this, I thank you for the attention. And I would like to try and give you a glance of how it looks when you're actually sailing in the Arctic, where you can see chunks of ice that are no less than 2 meters thick, popping on the sides of the icebreaker. So partially, this is how the cable lane will look for the icebreaker in the front. I hope you don't feel intimidated. This can be managed and still can be plowed through.
Amazing. Thanks, Evie. Any questions from the floor? Or Francis, you want to say?
I'd just like to add, I think the Asia-Europe ring and the APONET, the Pacific group, in actual fact, what you may not realize is there were over how many? 13 breaks on between Asia and Europe. There were 13 breaks in 2024. And I tell you, the breaks last for months. And I think the biggest one was about 2/3 of a year. And that's how bad it is. And the year before that, we only have three cable breaks. It is change. It has changed. And really have to thank the engineers who have managed to do all the backups so that you don't see it, you know? But that's how bad it is, you know? I have never seen so many breaks. And we were so frightened in June last year. Almost all our links, we got about 5 links to the US, and almost all the links were broken except one. Except one 100G link. And we all were crammed into that 100G link to take us. And that was thanks to the collaboration and the MOU that we signed for the AER and the APONET. Otherwise, if it breaks, that's it. The last one, we're just keeping our finger crossed. If it broke, then you know what will happen? Our traffic will go through the US. And that will be 400 milliseconds. That is our, I mean, currently it's about 200 milliseconds. If we go through the US to Europe, it's 400 milliseconds. Imagine, you can't do your Zoom anymore, literally, because it's going to be a walkie-talkie way of doing it, you know? So we really, shall we put our hands together to congratulate the engineers for doing it? Yeah. And so this is critical, this diverse part, because, yeah.
Thank you very much, Ms. Leva, for a very nice presentation, and task is really Herculean in nature. Just want to know at what depth actually this cable is laid actually in the ocean, Arctic Ocean, and how you have written, you have said in last slide that maintenance is around the, over the year it's possible. So how that is possible, maintenance of such cable which is at such a hard, ice below that?
So to answer the first question, so the depth in the Arctic Ocean varies from 3 kilometers to 4.5 kilometers in the deepest areas. So we think it's the cable will be safe there in the depths. Of course, on the shelves it's different, but we all need to land. So shelves, it's a different story. And that's why we didn't select the shelf route. And about the maintenance, so since Sweden is building a second icebreaker, and we're in collaboration with several commercial entities and discussing the maintenance plans and the feasibility of them. And one of the project's proposals that we have recently submitted will address the processes that we will create for maintenance, and the new icebreaker that Sweden is building will be capable of all year-round operations in the Arctic. So the ice in the central Arctic is not as hard. It's thick. It can be 2 to 4 meters thickness, but it's not that hard. It can be broken with the current Odin icebreaker, and it will be even easier with a new icebreaker. So we will gonna prepare plans for both maintenance and repair, and it's not gonna be easy, but it's gonna be feasible.
Thank you very much. Thanks. Any other questions for Eva? Okay. Thanks, Eva. Thanks for sharing.
Thank you.
Yeah, I think we're all looking forward to it. I mean, this being a shorter path, we look forward to the lower latency also through this link. Right. Okay, so next we have Steve Maddox from ARNet, and he's the Director International. I've been doing that for, I think, 25 years? No. Okay. Anyway, he's not on. Is he here? Oh, okay, so we'll skip. Okay, sure. Okay, so we move on to Chris Zen from UOH. He's the Director for Network Services. Yeah, so he will share on the Guam Open Research and Education Exchange, GOREX, upgrades and future opportunities. Okay, so I hand over to you.
Hello, everyone. Christine from the University of Hawaii. It's nice to be in Japan. I just got in last night, so I'm a little tired. So. This is a quick update on GOREX and the University of Hawaii. So GOREX was installed in 2017, back at our Trans-Pacific Research Education meeting, TPRE, in Hawaii in 2016. GOREX was just a little, PDF. None of this existed really back then. And it's hard to believe that GOREX actually turned 8 this year. So this was a notational map that David Lasner, the former University of Hawaii president, created back in 2016. Back then, the SX transport links were up, as well as some of the links between Japan and the US West Coast. But nothing was connecting Guam back to Hawaii or over to Singapore. So 8 years later, it's quite a bit of a difference in the Asia-Pacific region. APONET is a really good collaboration between everyone. It's saved us many times on cable breaks, as Francis had mentioned. And GOREX has expanded to quite a number of connections out of the GNC data center. Just this year, we turned up actually, in the beginning of February, in fact, we turned up the 1 gig link to Guam Community College. And then later on this year, we expect to turn up connections for the U.S. Defense Research Engineering Network, DREN, as well as the National Oceanic Atmospheric Administration for NOAA for the U.S. That will connect their resources in Guam back to the main networks in the continental U.S. At the end of January 2025, we replaced the Juniper MX480 with 2 Aristas. The MX480 had run its course. It still worked, but the port density and lack of future 400 gig upgrades was a detriment, not to mention the excessive power draw and enormous maintenance costs. We replaced it with 2 Aristas. The first one's a 7280 24D12. Second one's a SR340 YC6. So this gives us 24 100 gig connections and 12 400 gig connections, as well as many 1, 10, and 25 gig ports. So Gorex is now ready for 400 gig connectivity whenever that may come. And we continue to maintain Layer 2 VLANs and Layer 3 peerings with all the participants at Gorex. One advantage of getting rid of the 480 is that we now have a lot more room in the cabinet at GNC, which is next door to the SINET and Arena Pack cabinets. We added a 100 gig perf sonar box, as well as we moved the Pacific Wave iGrok server that was at University of Guam into the Gorex Colo and connected it at 100G. We used to have a APONET Mad Dash perf sonar dashboard that was running, but it's kind of not doing so well. So we recently started installing the newest perf sonar instance, which has a much nicer Grafana interface. So we'll work with all of the APONET participants and reach out to you folks again to try and set up a new APONET mesh so we can monitor the performance and troubleshoot anything that goes on. Gorex also participates in the AutoGoal Sense network. This is part of the GNAG working group. It actually goes through the University of Hawaii, so we have a bunch of VLANs across it, and the Gorex router is dynamically provisioning ports towards the iGrok server, the DTN in UOG, as well as the DTN in Kaus, which is in Saudi Arabia. This one actually connects through the NREN connection, but the actual interface that adds the VLANs dynamically is on the Gorex router. The AutoGo Sense folks are looking for participation in the Asia Pacific region. So if anyone is interested, I think there's a GNAG working group later on during APAN, or you can reach out to me and I can get you in touch with those folks as well. We also want to say thank you to the University of Guam. They have been the remote hands for Gorex for the past 8 years. They've saved us a trip to Guam, which is a very long way from Hawaii, as well as a very expensive trip to Hawaii. It's about $3,000 economy round trip. Yeah. That's because only United flies there. They have a monopoly on the route. University of Guam actually moved the Gorex colocation cabin. It was at the GTA central office in Tamuning. They actually disassembled everything, threw it in the back of their vehicles, and drove it over to GNC and put everything back together in a day. So we're very appreciative to them. And that was in the middle of COVID, so we couldn't have gone anyway. So moving on to the University of Hawaii updates. The biggest news is that we're building a new inter-island cable system between all of the islands. Currently, the 2 cables, actually there's 3. 2 of the cables that connect all of the islands together are 25 and 30 years old, so they're well past their lifespan. The other one's about 15 years old. And all 3 cables are owned by the same local exchange carrier, so they have a monopoly on the market. The University of Hawaii has partnered with a private entity, Ocean Networks Incorporated. Using some of the federal monies, we are splitting the cost of this new cable. The state of Hawaii will then own 20% of the cable, and the best part about it is that we will not be responsible for any operation maintenance costs for the life of the system, right? So we get a dark pair on each segment. This is a unrepeated system. The longest spans about 238 kilometers, and we're expecting about 400 gigs per wavelength between any of the points across the system. 5 of the 6 cable landing stations in the state are located on the University of Hawaii campuses. We're either retrofitting existing spaces or building or installing new modular cable landing systems. And this is key because it connects to our inter-island network, or I'm sorry, our on-island networks that connect up resources on the Mauna Kea, Haleakala, Mauna Loa summits for the observatories. RFS date is in December 2026. You can see the timeline there below. We did our desktop study back in 2022. We're now doing all of the permitting work, which takes an enormous amount of time. We just signed the horizontal directional drilling contract with the contractor, and they should be making a selection of the wet plant and marine installation contractor by the end of March. So it's exciting. First time I actually had to build a subsea fiber system and all of the permitting, and it's not very fun. So what's interesting about the other one's called HIFO, Hawaiian Islands Fiber Link. So what's cool about HIFO is that on the UH West Oahu campus, which is on Oahu, the cable landing stations actually be in the same landing station that Google's Pacific Connect initiative is dropping their cables into. So Google has a lot of cables in the Pacific, as you folks know. There's 3 landing in Hawaii, the Taihei, which is Japan to Hawaii, which is sorely needed because the Japan-US cable went out of commission. They turned that one down. So there's no direct link between Japan and Hawaii anymore. The Tabua cable, I think that's going to be a branching unit off of the existing Tabua cable or the Tabua cable that's going in the water now. And then they're going to install another cable between Guam and Hawaii. So we're really excited about this. Since we're in the same landing station as Google, there's potentially a 0-mile access to capacity on the Google system. I don't know if they have decided how they're going to sell it. I've heard that the minimum is a 1/4 wavelength across all of their things. And I don't think they actually know how much it's going to cost either. So that's another thing that we'll have to figure out. Yeah. Francis said free. Thank you, Francis. So this should be, I would say, their RFS date is probably around early 2027. So our inter-island system is going to beat it. And the cable landing station will probably be around the same time in the 2026, beginning of 2027. So that should be exciting. I think there's a lot of promise, but of course a lot of it depends on their commercial, what they want to charge everyone for that. So that's all I had. Thank you very much. Any questions?
Yeah. Any questions for Chris? Francis, you have anything to say?
No, I just wanted to ask. Okay, Google is doing this. Meta announced they were doing another one. Does the Meta cable go? I know it passes through Australia, right, Warrick?
Yeah, I think
northern part somewhere.
It's taking like the southern route. It's all kind of on the southern hemisphere.
Yes, it's all southern hemisphere.
I think we looked at a slide and there's a big blue dot somewhere around Australia that wasn't very obvious where it landed.
Darwin.
Yeah.
Is it Darwin? Let's put some bets on it. Yeah, but that's another one which actually provides possible resilience as well for all of us.
We're just not sure where their landing is going to be.
Yeah, we're not sure.
Yeah.
I'm not sure whether they know where the landing is.
Probably
yet.
not.
Yeah.
Even the Google ones, we're not sure exactly. They haven't really released where everything is going to be. So I'm not sure where it lands in Guam. It doesn't land at the same location where Gorix is, though. I'm pretty sure it's a different landing station or different CLS. Yeah.
Okay, because then you have to.
We'll have to find a way.
loop.
If we get capacity in the Google, we'll have to find a way to get bandwidth across the island, which is very expensive.
Yeah, I think sometimes the local loops are really, really expensive. It depends on whether there are multiple people or is it a monopoly. Yeah, thanks.
Thank you.
Thanks, Chris. Okay, next we have James Deaton. He'll be sharing on the ANA updates and so.
Well, if any of you saw Francis walk up to me right between sessions, he pointed out that I was talking. So forgive me on the slides. No, I'm kidding. I had luckily looked into the details and saw it on there. And given the fact that Warrick doesn't want to channel Steve, I've got more time. So I'm going to make it more of an international update instead of just ANA update. Plus, I've got 1 second. Good morning, everybody. All right, no, a full minute. I'll be the last person to say good morning. So real quick, obligatory topology map. I'm not going to go into the details, but you've probably seen this times before, updates from colleagues here in the room. But so since we're talking international, I just wanted to highlight some of the programmatic highlights here. One of the proudest moments, the first thing on the list, is Internet 2 in the past year joined NEAR with our friends at International at IU. And so very happy, and I'll get into some of the details of what that meant. We've been working a great deal on some of the GNAG and the ANA engagements. One of the things I'm not going to get into a great deal in this slide deck, but I think it's very important, especially with some of the things that have been said earlier. We've been doing some really enjoyable network research, helping do some combination of active discovery and understanding some of the lack of maybe understanding of BGP implementations. And so we just within the US have found a growing number of expectations diverging from what we should see within the network when it comes to leveraging research paths. And so I would be happy to talk more deeply about some of the stuff that we're doing with the NSRC and CADA with BGP analytics, because it's going to factor in even more from an international peering perspective. And then we've got a lot of great new team members, and honestly, some of the folks in this room should be up here talking, but I think Francis likes to just put me on the spot. Also want to go through some quick technical highlights. I might as well just jump straight into the slides. I've got stuff that covers all of this on future slides. So I think the one thing I don't cover is we're in an active evaluation of some new platforms that could potentially make it into the network. So we've got a lab that's got all sorts of folks tinkering both internally and within the community, looking at our paths forward to support 800 gig and some broader, more flexible MACsec needs. So I'm in the program as talking about the ANA. Raise your hand if you touch one of the circuits on the ANA, like it lands in your network. Okay, so everybody that's raising their hand, some people aren't, okay. You know, they're in better position to talk than I am here, but it's exciting. We're up to 3.1 terabits, almost all active now. Is that correct? Is that right? That's changing rapidly. When I started less than 2 years ago, and it wasn't even 2.4. So it's changing very quickly. I was very excited because a couple of the links were just turned up right after APAN last year. We had 2 new 400 gig links brought up that we worked on with Canada, with Canary, and we're sharing with Canary, and for ESNet. I'm reading some of the faces in here so I can get called out. In fact, we do have microphones, so you can publicly shame me if I get some of this incorrect. You can definitely read many of these links. When we just happened in the past, how many weeks? We can still count weeks instead of months, right? For the SINET link, that was last week, right? So we can count hours. Can we get an hour count in the room? All right. And then we already know that there's quite a bit of new spectrum capacity coming up, both from the GEONT side and from the ESNet side of the house. So it's pretty exciting to see this capacity come up. And Francis talked about the resilience. It's incredibly important to have the number of links we do, and of course it introduces a ton of complexity, making certain that we can land these connections at the right places. I like the last one. For those of you that were at the SINET, there were a number of national or network research experiments. Brenna, how many network total NREs? 36. And you see here, there were, these links actually were involved in at least 25 of those 36. So it's exciting to see this footprint have an impact on incredible demonstrations that are happening. So one of the things that's really nice is to see us finally stepping into leveraging AutoGo on our side of the Atlantic. And we're working, collaborating with our great friends at SURF, to work on this. And it's moving along at some pace, right? So, and I'll get into that too. So the piece that's, when I say some, when we're adding that many links, how many, what's the total count here? Come on, I'm checking with the engineer. Raise your hand if you're the chair of the engineering committee. All right, thank you. So with the 11, it's adding quite a bit of complexity. So being able to deploy the software mechanisms to orchestrate across this network is critical. And so at the same time, we're doing crazy stuff like replacing all the hardware underneath it. So like right here, you can see the GXPs that we're involved in on the East Coast in the US, Boston, New York, and Washington. And I'm too lazy. We actually have a name. I think it's just a Boston IX, right? Is that BIX, BIX? So I was too lazy to get rid of the TBD. So I was shooting for other nicknames, but they all got shot down. I'm not going to share them here, but it's now BIX. But so that process is underway. We just finished it, what, maybe not even 6 months ago. I'm trying to make this an interactive session. All right. And so the complexity has highlighted opportunities for improvement, right? So the ANA collaboration has been around for, help me again, raise the number of fingers. 12. See, you don't have enough. It's been around 12 years. And so there's been a kind of a reboot in a strategy associated with this. So the CEOs of many of the partner networks that have put this together have identified basically a planning group. Basically, the CTOs are the equivalents, and they're actually going to come together for the first time next week underneath this new initiative. And so the idea is so that we can take, the directives of the CTO and the individual desires of the organizations and actually map them into a set of steps for the engineers. And so within the engineering group, they're busy with a multitude of awesome opportunities to improve things like adopting AutoGo and leveraging the management of how many different VLANs are currently across the ANA? I think it took like 5 spreadsheets, 2 different supercomputers, and it's amazing. It's quite a complex set of things, but the resilience that it's providing is worth it. So these are the set of things that currently the ANA Engineering Working Group is working on. I don't know if this is of great interest at this talk, but the gentleman at the very front of the row, Ed Moynihan, is intimately familiar with all that. We've got a couple of members. Thomas, raise your hand. You're part of this group. Raise your hand if you're in ANA Engineering. Yeah, look around. See, there's plenty of great people that if you've got any questions about this, yeah, applaud them. I mean, they're the ones doing the things that Francis is talking about, making certain that the point A gets to point B and it doesn't get confused with the other paths. So one of the things that I'm excited about within North America is the fact that we have had a mix of various sources of funding to bring up these connections, whether they're on the East Coast, the West Coast, or down south. We've got a mix of sources of the links. And so if you look along the right side of this map, I don't know how easy it is to see, these are all folks that are playing some role in connections coming into North America. And so they've gotten together and they're trying to make magic happen across the continent. And so raise your hand if you're part of NREX. Come on, there's some people in here. Wait, raise them like you mean it, you own it. Come on. Josh, come on, there you go. So they're coming together and taking opportunities to standardize the ways that we work across this. taking the same software we're using within the ANA system itself, trying to make sure that we're getting either end, either coast, north or south, and be able to provision the connections. And so I think I've got a little bit more detail here. So it's definitely a work in progress. It's amazing to see that we're turning up these permanent, basically express paths across the U.S. To make this nice and hopefully ultimately easy. And again, these have played a great role within the NREs at SC. They're playing a great role in testing of international connections across multiple projects. And ultimately, we hope that some of the things that we heard about like yesterday, Simon, are you in the room? Oh, there you are, Simon. I was mesmerized by some of the things he talked about with APONET and the engineering happening over there. And so I'm excited about the opportunities that NREX and ANA and APONET can start doing some stuff together so we can start talking a single language when it comes to automating these activities. Can I use that word? All right. So I'm getting a little jazzed up here because it's all these people talking and all these pieces and components are finally getting surfaced. And so maybe we can see some magic happen from that. So I'm very excited that in the time that I've been here, I've gotten to see the hardware swapped out, that we're enabling the capabilities with the GXPs on the East Coast. It's in lockstep with the GXPs on the West Coast. We're lifting together the GXPs down like in Atlanta so that they're more capable to serve really exciting new projects in the future. And so it's really, really great. So hope you didn't mind this international message. And so, of course, NREX is definitely playing a role, like I alluded to with some of the things that we heard about yesterday. So with that, come on, questions, comments. Raise your hands if you're excited about the ANA work.
No question, but
yeah?
It's amazing. Do we get 12 here at now, ANA? We started with one link, went to 2 or 3, and we were talking about backing each other up. But we're now evolved into a system that's inherently resilient for us. So that's really amazing what we do, and yet the complexity with automating that's perfect when we move on with that, I would say. So I'm super happy with the things that are going on, and amazing when we can glue those systems together on a global scale as well.
Without a doubt. I'm very excited about some of the things that we're talking about from a software perspective. The language about the sharing of telemetry associated with this. I mean, one of the I glossed over several of the bullet points. And so one of the things that was very exciting to me was when we started contributing more directly to activities like NetSage. More broadly, from a number of us, including Jayant, have come together and are contributing to concepts like Metronova, so that we can come together with a set of policies and practices for sharing enough data about the network so that we can start making a proactive, orchestrated decisions to fix the networks. And so it's exciting to see some of that. And this is just a plug. If anybody wants to hear about what we're trying to do from a new perspective within the U.S. That I want to see adopted elsewhere, we try to identify about 5 objectives that are very distinctly unique that RENs can do that you don't see in the commodity, internet. And there's a whole set of things that we're doing underneath each of these things that I feel totally differentiates what we're doing in this room from what the ISPs are doing. And so I'm locking all the RENs in the U.S. together in a room in 3 weeks. I'm stressed out about it, but it's going to be exciting because we're working on ways that we can communicate the value propositions of the networks and be able to start talking to a point where we're sharing the right data, being intimately familiar with the policy, the practices, the routes, and basically lift everybody. So anyway, thank you. Any other questions on ANA side or international? All right. Well, good afternoon now.
Thanks.
Thank you.
Thanks, James. Okay, we've come to the end of this session. Thanks, James, and all the speakers, and have a good lunch. I think the opening ceremony is at 1:30, so just note that. Thanks.